In the last video, we created the response struct, but we didn't implement the status code enum. We just have a placeholder for now. Let's create a new file under HTTP, and we can call it status_code.rs. And we also have to pull the new status code module into mod.rs. Okay, now let's look at the possible status codes. Here is a list of the HTTP status codes, and we see that there are a lot. We would not implement all of them because that won't really aid us in our goal of learning Rust. So let's just implement the most useful ones. We want 200 OK, so that we can return successful responses. We also want 400 bad requests. We will return this when we fail to successfully parse the request. And we want 404 not found. We will return this when an unknown path is requested. Let's create an enum with these variants. So we want our public enum called status code. And in it we have OK, we have bad request, and we have not found. But we also have to map the variants of the enum with the actual status codes. So OK is 200, bad request is 400, and not found is 404. To do this, we can take advantage of the nature of enums in Rust. Remember that underneath a simple enum like this that doesn't wrap any additional data in the variants is represented by a single number, and we can assign the value that we want for every variant. So here we can say that OK is actually 200 and bad request is actually 400. Not found would be 404. That way we can still use the user-friendly names of these status codes throughout our code, but when we want to generate the response, we can just cast this status code to an integer and send it down the socket. We would also need a method to map these variants to the correct reason phrase, because remember that in a response we have to specify the number of the status code followed by the reason for the status code. So let's create an implementation block for status code, and in it we want to create a public method which we will call reason phrase, and this will take a reference to self and will return a string slice because we will just return static strings. In here we can just match on the self because remember self is an enum, so we can say match self, and then all the variants would be self OK, and the message for that would be OK. We have self bad request with a message of bad request, and we have not found with a message of not found. Now all that's left is to add functionality for casting the status code to an integer. To make this even easier to use, we can directly implement the display trait on the status code, and it will print out the actual number that the status code corresponds to. That way, when we are building the response, it will be really easy to concatenate the status code with the rest of the response. To implement display, first we have to import all the necessary structs that we would need. So from the std_fmt, we import display, the formatter, and the result, which we rename to fmt result. Now down here we can implement display for status code. And as we remember, display requires us to only implement the fmt function. So it takes a reference to self, and it also takes a formatter which we will call f, and it will be a mutable reference to a formatter, and it returns an fmt result. And now we have to use the write macro to write to the formatter, and as a second parameter, we pass a format string. In this case, we just put a placeholder, and as the third parameter, oops, that should be after the quote, as the third parameter, we put the actual value that we want to substitute here. So how would we cast this enum to an integer? First, let's think about the type of an integer that we need. It will have to be unsigned because the status code cannot be negative, and the numbers go up to 500 and something, so it won't fit in a U8. That means that we have to use a U16. And to cast something to a primitive type, we can use the S keyword. We can just say that we want to cast the self as a U16. And of course we get a compilation error. We see that the compiler complains that we are casting a reference to a status code as a U16, and that's invalid because we are casting the reference. And remember that the reference is just a pointer. What we're trying to do here is cast the address to the enum into a U16. What we actually want to do is cast the thing that this reference points to. And to do that, we have to dereference the reference. We've done this already. It's done by putting a star before the reference. Now we are telling the compiler that we want to cast whatever this self is pointing to into a U16. But of course, we get another error. It tells us that it cannot move out of the self because it is behind the shared reference. And underneath, the compiler gives us a hint. It tells us that it's trying to move the self because status code does not implement the copy trait. Okay, let's explain what copy means. Generally, we can think about the values in our program in two types. Those that live entirely on the stack and those that live on the stack and on the heap. Types that live entirely on the stack can be trivially copied just by copying their bytes. An example for such a type is an integer. The integer is just a sequence of bytes that are stored on the stack, and if we copy this sequence, we have copied all the data for this integer. On the other hand, we have a string, for example, and the string is not a copy type. Let's think about that. How is the string represented? On the stack, it only stores some metadata like the length of the string, and it stores a pointer that points to the heap where the actual text lives. So by copying the bytes on the stack, we don't copy the whole string, we only copy the pointer and the metadata. That means that the string cannot implement the copy trait. For complex types like this, there is another trait called clone. Clone provides functionality for creating a deep copy of a value. A deep copy means that the clone function will do extra work to also copy the necessary heap data. Okay, now that we know about copy and clone, let's look at our status code. As we said, it is represented by a single integer. That means that we can implement copy for status code because it will be trivially copied just by copying the bytes for the integer. And we don't even have to manually implement copy. We can use the derive attribute that we used before with the debug trait. So above the status code, we can say that we want to derive the copy trait. And we get an error here. We see that when we scroll down to the actual error, the compiler tells us that we have to implement clone in order to implement copy. So when we want to implement copy, the compiler will force us to also implement the clone trait. The reason for this is that if a type implements copy, it can have a trivial implementation for clone that would perform the same task as copy. So to also implement clone, we can just put a comma after the copy and say clone. Now we are deriving these two traits for the status code. And we see that now the compiler is happy with us casting the enum as a number, because what it will do is it will copy the contents of this enum and treat them as a U16 without moving the enum itself. One last thing, we also want to derive debug, because it is just a good practice to derive debug on all of your types so that later you can log them easily. Now we can go to mods.rs and export this new type. So we can say pubuse from status code. We want to use the status code. And if we go back to the response, we can change this temporary enum here with the actual status code that we implemented. So we want to say use from super, we want to use the status code. And we can also derive debug for the response, because all of the subtypes in the response, like the status code, already implement debug.